Great. Okay.
Can I get started?
Sure, I think so. People might still trickle in, but yeah, you're welcome to start whenever.
But you can do it.
Does this work? I'm not sure.
Where's John?
All right. Hi, everyone. My name is Elise. I'm going to use a microphone just so it records a little better for those who are joining us remotely. But yeah, I guess first, Alexa and I are going to be co-teaching this today. I was a graduate student at Bren, and now I am working for the Institute for Energy Efficiency on campus. And my experience with GitHub thus far has been using it for website development, so like back-end and front-end code, working in a larger group of researchers who do code in Python to build models that our computer science intern will then turn into a website front-end. So it's a whole bunch of different languages. We're all collaborating together, trying to build one product without breaking anything, which is a challenge. So how this is going to work is that I'm going to introduce you to basically the verbiage of GitHub, the words you need to be comfortable with, then talk a little bit about the problems that it can solve in terms of scientific collaboration and why would you use it. And Alexa is going to walk you through an example using GitHub with R. So buckle up. I guess I'll just sort of do this when I need the next slide.
Yeah, perfect.
So if you've ever been a student, you've seen a folder like this, maybe less so now with Dropbox, but the idea holds still. You're sending something out for review, getting feedback, while your professor, whoever is looking at it, giving you comments. Maybe you catch a typo, you correct it. You get the feedback back from them and, oh crap, now we need to merge these changes. It gets complicated even just with Word files. And then try to imagine what this would be like if you needed code to run and accomplish something. And you missed a variable change and it didn't get changed over. I don't even want to imagine. So you use GitHub to avoid this, especially with functional code. So what that is called is version control. It means that instead of a folder full of documents with different names that try to cue you in on who reviewed what, you have something called Git that sorts through your changes, marks who did what, and you don't see any of that. All you see is the most recent, and if you want to, you can go into GitHub and you can say, who changed this line? Oh, that's right. Paul changed it, and it was because of X, because Paul helpfully commented his code. This is the ideal. So version control is very attractive, and it's not limited to one programming language. You can use Git and GitHub for anything. You know, Python, R, JavaScript, HTML, CSS. Yeah. So yeah, you can see how this would be really powerful for groups working together, but also for you on your own if you're working on a project. Yeah, if you've ever tried to come back to your work 3 months later, you're trying to remember why you made a decision. If you haven't been commenting your code, that's really tough. And Git helpfully reminds you to add a comment every time you commit a change, which we'll get into. But it really encourages you to have good studious habits and keeping track of what you changed, why, and how. So I guess I kind of covered this already, but it actually does keep the files locally on your machine. So that's in a way similar to Dropbox. If you've ever synced it to desktop, you'll have a file on your computer. I usually make a folder in documents called Git, and I'll put all the stuff in there. So you will have live files on your computer that you'll be editing and running code, seeing if your edits are working. Yeah, it's all local, which is nice. You do have much more control about when it syncs. If you're working on a Google Drive doc, everything's syncing immediately. But if you've ever had an opportunity to write code and you're thinking, okay, could I do this better? Oh, what I thought would work wouldn't. You don't want it to be live updating. You want time to trial and error, figure out what's going to work, and then once you settle on your beautiful baby you want to share with the world, then send it. And GitHub allows you to have that sort of fine control over the changes you're making to code. Even more helpful, you can revert back to a previous version because every change gets a name. I mean, it's not a name like you would recognize. It's a string of numbers and letters. but it does help you be able to go back really granularly and say, wow, I changed this and it was a bad change, but I don't remember what was before. You can go back and look at the history of that file. Also for collaboration, there's a feature called Issues, which is essentially a to-do list that you can assign people to, which is super, super helpful. So, okay, without any further ado, here is sort of what we'll be working with generally. Like I said earlier, Git is actually a program that runs locally on your machine. It is what does all of that indexing of changes. It's the organizational system. If you're going to be syncing to GitHub, which is a website, and we can use the magical in the cloud language if you like, what it does is communicate with your local version of Git so that you can have those files on GitHub and be able to collaborate with other people's local versions of Git on their machine. Github.com is the website. You'll need an account for the run through later, the example that Alexa will take you through. It's all free. And the way that you interface with your local Git and between that and GitHub, there are a lot of different ways. If you're familiar with the command line and you're comfortable there are a lot of really simple ways to follow the workflow without leaving the command line. If you're not, and when I started I really wasn't, there are a lot of graphical user interfaces you can go through that just make it super easy. It's just like using any other program. GitHub Desktop is a great one to start with because it's not specific to any programming language. It takes that folder in your Git folder and allows you to go through the workflow without being specific to any programming language. It's really nice when you're in the editor for your code.
Elise,
yeah?
Your battery died.
Oh no. Thank you.
Mm-hmm.
Wow, you come prepared.
I just got them this morning.
Thanks.
Mhm.
Okay, neat. Yeah, that last thought was basically, if you're editing code in R Markdown or in another IDE like Atom, which I really recommend, it's really nice when they have a built-in button to commit, and it just simplifies your thinking and your working. You don't even have to go to the command line. So those are at least 3 different options to interface with GitHub. Command line, an in-editor functionality, which RStudio has and Atom has, or going to GitHub Desktop, which is a separate software that manages that file. And you can work in the files within that folder in any way you like. Just open up GitHub Desktop when you want to sync it. Great, okay, so enough talking about what I'm going to talk about. First I'm going to go, I kind of already went through the structure, and then next we're going to look into the vocab of the workflow, and then we'll do the practice, and you guys will get to do it yourself. Look at resources. All right, so say I'm working on a project, and I have my code base, and I want to edit it and fuss with it. That's going to be called a repository. So just like I was referring to earlier, you have your folder that has all your code in it for that specific project. You might as well start thinking about that as your repository for that project. Everything's all together. It's a bunch of different files that interact with each other in different ways, and they're in a repo. Those in the know like to call it. So you can see here, this is a repo called genetics. And it probably has a lot of cool genetics up in it, because I think that's in yours.
No, project totally didn't work.
Oh,
but thank you.
Neat. So this is kind of what they look like. This is what you see if you go on github.com. So this is an in-browser view. There are tabs at the top. You can see that code is where you'll go if you want to look at actual files and see the lines of code, stuff like that. Issues will be if you have a to-do list. This is mostly helpful if you're working with people, but it also helps to organize your own thoughts if you're trying to plan out the future of a project, or you're trying to think about, okay, well, what do I need to work on to make this functional? Do it that way. Pull requests are the way that GitHub handles reviewing. So if you have asked a friend to, like, hey, you want to work on this project with me, I need you to do task A, they'll work on that on their local machine in a sort of parallel branch. And when they think they found a solve, it's considered polite to request for the first person to review it. So they'll make a pull request. They'll say, hey, I wrote some code. I think it's great. Will you review it before we put it into master? Take a look at it. You run a practice. if it doesn't mess anything up, you say, yeah, sure, let's put this into the main repository. So pull request tab will be where you review different things people are suggesting that you incorporate. And the rest I've honestly never used. So I'm not even going to pretend. Okay, so I went over what repos are. They're those folders that contain your code. Everything is tracked and changes are attributed to contributors. Yeah, no matter what sort of project you start or join in a group project or at a new job, the structure will likely be similar. You'll be in a repo. I was definitely,
My bad.
I was definitely really surprised to learn that organizations like Twitter, Netflix, I mean, even RStudio, they all use GitHub to render their base code, or not to render, but to write and collaborate on making all the stuff that underlies these big projects. So it's really effective. Once you get the hang of it, it's like breathing. You'll really understand it, and it makes sense. And I mean, if it didn't go wrong for them, then it could probably work for us, right? Okay, so I already said that 5 times. Okay, so there are a bunch of different ways that you might want to start using GitHub. Either you have a group project and you guys want to collaborate together. You start a new job and you're like, okay, I need to start contributing to this project that people are building, money. Or you might find someone else's neat idea that you think you can adapt. For me, one of the first times I used GitHub was in a magazine. I saw someone had made a program to hook up to a water hose that will automatically water your garden. I thought, that sounds really cool. But you know, in Santa Barbara, we don't get a lot of rain. I would need to edit that code to change how often the watering machine or whatever would open up that valve to water the garden. So in order to do that, I would need to sort of get into this GitHub pattern. I need to figure out how to get the files onto my computer, I need to edit them, and if I wanted to tell this guy, hey, you should have a version for non-rainy places, I could suggest, create a pull request, that he take my edits back into the main line of code. So the first step is, it would be nice if the files were on your computer. Next slide. So what you do is you clone. You clone the original repository. So for my example with Magical Tomato Watering Guy, I went online, found his GitHub repository. This is something you're doing in the browser. So you're on github.com, you find a repo, and you clone it. And again, we're just getting used to the vocabulary. Alexa will show you how you do this. The next thing you do is you start working on it, right? So you have ideas, you work. You can even save on your local computer, but it's not tracked yet because you haven't committed. It's like what I alluded to earlier. You're trying new things. Maybe you write some bad code. Maybe you have to stop and look up stuff and try something different. But when you're at a point where you think you have something good to contribute, you do what's called committing. So it's sort of like a little mini celebration of, I did something. It's really small. It's a self-contained feature, and I'm going to commit it. You should also add a comment, like, I don't know, change the days that the tomatoes get watered, if I just went in and changed a number. This is an example of the XKCD guys' commit messages. And as you start making more and more work, you get a little bit lazier. But if we were working on Julie's map, our first step would be to clone, then we would work locally, and then we would commit our changes. This is still just on our local machine. But again, you're working with your local instance of Git to keep track of different changes you're making to the code. What did I add? If I want to undo this later, will I know to come back to this step? It's basically, you're trying to help out future you. Okay, but if you're in a collaborative project, while you're sitting there working on perfecting your next feature, someone else might also be working on something, and they might push it back to the main repository before you're finished. This is where probably the most annoying thing that happens when you're working with GitHub comes in, is that when you try to merge your changes back into the master file, you'll get a message that says, well, this conflicts. You changed something that someone else also had something to say about. And Git is very conservative. It doesn't want to guess whose changes are better. It will come back at you with a message that says, I've printed out both versions in the file. Now you go in and delete the one that you don't want to keep. So I got off track there. What I'm trying to say is, in order to tell if someone even changed anything in that master file, you have to do something called pulling. And what that does is it looks it up on GitHub again, more recently. It's like a refresh button. Is there anything different than when I cloned this repository? And it'll bring in the new changes to the file. What I was talking about earlier was if there is any changes, you have to resolve those conflicts. But if you're lucky, it'll just happen smoothly. So yeah.
We talked about that.
Yeah, I guess I kind of didn't cover that. Okay, so pull is like the refresh button. You don't use clone more than once. Clone is like the first time you'll only ever clone a repository once if you're lucky. And then after that, if you want to refresh, you'll use the full command. Thanks. Okay, so you've cloned, you've edited, you've pulled to make sure there are no changes from the GitHub version. Now you can finally say, okay, I'm pushing everything I changed to be in this glorious master copy held on github.com. So that's your next vocabulary word is push. Pushing your changes up there. One really cool feature of GitHub is that if you really want to try something crazy, you don't have to risk messing up the master branch to keep your work saved on github.com. So what this represents is sort of the different versions of the file you're working on. So that straight line up top is the master branch. And for me working in web development, that master branch is basically what the customer sees when they go to our website. So you're trying to keep that sort of pure and functional. And if you decide that there's some new feature you want to add to your code, you don't want to mess with that. So you create what's called a branch. You branch the project. And now there are two versions of it. The master one, and you'll create a name for this branch. I think my first branch was actually called Elise Zone. So it was just where I went to experiment with stuff to figure out how I could implement the features I wanted. Typically, you'll create a branch for each feature if you're working in a larger group. But the idea here is that each circle is a commit. So you'll create your branch. You'll make commits for the different features that you're adding. Like, okay, I figured out how to do X. I figured out how to do Y. Figured out how to do Z. And then this next symbol is a pull request. You'll go back to your group and say, hey, I made a pull request. What do you think of my code? And then all those little speech bubbles are discussion. We would say, you know, X doesn't really work under these circumstances. Can you change the code to work in a broader context? You'll make more commits to address their comments. And for some reason, I can't figure out this squirrel on the right is perfection. So you eventually get to a state where your code is functional. Other people agree. They think that it adds and it doesn't create any new problems. And then you'll merge it back into the master branch. And now everyone's master working copy will have your new feature in it. Yeah, I've got a question in the back.
Does everyone agree? Does that mean that nobody has any comments or anything like that?
So the question was, does everybody agreeing mean that nobody has any comments? And I guess Git doesn't really have a conflict resolution feature. This is probably more applicable if you're in a professional context. Like if you have a boss who has to sign off, maybe they'll be the reviewer. But it's more of a conversation. So if people really have differences of opinion, you'll have to figure out, you know, who wins out. Was that the purpose?
Yeah, I mean, I guess so. It's whoever gets to do that last pull person.
Exactly. I think that's a setting you can change on your repository if people can review their own pull commits. Pull requests. So you can either set it so that another human being has to go in and click pull request, and you hope that they're not being a rubber stamp, that they're actually looking at it. Yeah. All right. So just to make it even more fun, there are multiple ways you can go through this workflow. The one we just covered is probably the simplest, and I think the most straightforward. You clone it, you clone the repository, get the code on your computer, make the edits, pull again to make sure that you're still working with the same copy everyone else is, and push to the master branch. If you want to do something crazy, then that's fine. Make a branch, edit it, make a pull request. Maybe it'll get brought back into that master file. There's something else called forking. With your account on GitHub, you can have as many repositories as you want. I mean, That's great. If Alexa has a repository I want to work on, but I'm not necessarily in it for the collaboration, I think it's a great idea and I want to work on it and expand it in my own direction, I can basically copy her repository to my account and create my own fork of that repository. So when I read about that guy's cool tomato watering thing, I didn't like request to be a part of his project because I didn't know him. He's a stranger. Strangers are scary. What I did was I forked his repository into my account and played with it in the safe aloneness of my own GitHub account. So those are two different ways that you can sort of interact with repos on GitHub. So this is kind of a summary of what we've learned. Julie's Mac situation over here is the way you would think of just starting out. This is what you're going to be doing today. You're going to clone, pull a bunch because you always want to be clicking refresh. Work locally. You can save it to your computer, but it doesn't really matter until you make a commit, where you write your little note and say, yes, I did a thing. Then you're going to push back up to the GitHub repository to have improved everyone's life forever by making cool code changes. Jamie's PC over here is a good example of the workflow you'll get into when you're working on a project over time. You won't necessarily be cloning, but you will start up your PC or your computer, pull to get the most recent version, work locally, commit changes, pull again, just for paranoia's sake, and then push your committed changes back up. And this is an example of the fork repo I talked about. You'll have your original repo you think is great. You'll fork it into your own environment under your own username in GitHub, and the same thing applies. Clone, commit, pull, push. If you really want to make friends, you still have the option to ask the original repo for a pull request. Say, hey, I think I actually improved what you're doing here. Consider these changes. Check this out. It's not like you're forbidden from doing that, because I guess everyone wants all options all the time. But it just has sort of different purpose in my heart. Okay, so thanks for bearing with me. Now we know what fork means, clone. I guess we always knew what editing a file meant. Commit changes, pull, push, and then you'll get into your workflow of pull, edit, commit, push. And I guess with that, I'll turn it over to Alexa.
Thank you so much. I realized I committed a minor error when teaching this tutorial, which is that I normally remind everyone to go to the repository before coming and follow these 3 steps to set up GitHub on your computer. Setting up Git on your personal machine, if you haven't done it, can take a minute. Can you, as a show of hands, show me who already has Git on their computer? Okay, that's most of you, which is great. If those of you who haven't still want to follow along, if you can go to the URL on the top, which is also in the email, and follow these 1, 2, 3 steps, that will allow you to participate in the rest of the demo. You can also look on with someone else if you don't want to do that this second. But this is a great place to try it because we have a number of helpers. So can the people who are able to help others with their GitHub raise their hands? Okay, anyone not with your hand not up, look around and remember these faces. So the people whose hands are up are runners. And when you have an issue following along, grab one of them, put your hand in the air. We normally have a Post-it system. We don't have colored Post-its today, but flag down any of those people and they can come sit next to you and quietly help you work through whatever you're stuck on. Sorry? Student account for GitHub, yes. So GitHub, you always want to have a student account because you get a bunch of free stuff. If, for those of you who aren't students, if you can trick it into thinking you're a student, go for it. Otherwise, I'm sorry. Exactly, perfect. So if anyone with a ucsb.edu address should be fine. And we're going to use today the GitHub interface in RStudio. So Elise told you there are a lot of different ways to work with these concepts of pulling, committing, pushing. There's a built-in pane both in another program, Atom, and also in RStudio, which is how I code. And I think a lot of people at UCSB code. So that's how I'm going to be showing this to you. But you can do this from the command line and a lot of different ways. The concepts are all exactly the same. Are we ready to get started? Okay, so the first thing you're going to do, let's hope that you're all on this page, and you can actually see, so cloning basically means you're downloading the files in this repository onto your local machine. Forking is a slightly more confusing concept. To me, Elise did a great job of explaining that that just kind of makes it yours. It's in your own computing environment on GitHub now. And you can actually see this repository I created under my name, and then I logged in as Eco Data Science and forked it from myself so that it's under the right account. So that's one way to use it. And another way that I often fork things is if I want code for since I mostly do scientific research, if I want the code for someone else's scientific publication that they put online, I'll just fork the repository for a publication of theirs and read through all the code. So you are each going to get your own copy of this repository by clicking the fork button in the top left. And when you do that, it will take a minute and kind of refresh the page, and then it should say your username / GitHub intro 2. Please give me a thumbs up when you've done that. Great. So now you have that repository in your own environment, but it's not on your computer. And what we're going to do today is actually edit some code and then put it back on GitHub so that you understand this workflow. So to get it onto your computer, what are you going to do? Clone. Great job. So you're going to press this clone button on the right and just click this little icon that copies the link that it provides. That's all you have to do at the moment. Now, let's go to RStudio. So RStudio is a very popular interface to the programming language R that manages a bunch of stuff for you, including version control with Git. The way it does version control with Git uses something called R projects, which is another way to organize all of the files in a folder or a repository in addition to just the fact that they're in a literal folder. It kind of more fundamentally wraps them all into the same group so that you're always opening and working from the same working directory and set of files. So to work on this repository on your local machine, you need to start a new R project for it. So you're going to go to File, New Project. Come on. Perfect. Is everyone here, more or less? Great, I see nods. Now, if you were just working on your local machine, this had nothing to do with GitHub, you might just click New Directory. But here, we're going to use the phrase we just learned and use a version control repository. There are two options it gives you. Use the first one, which we just learned about, Git. Click on that. And here's where you use the URL that we just copied. So you're going to paste, nope, that was me grocery shopping. See, I think this would happen sooner or later. That's my all-important question to my sister who works at a grocery store about their chicken sausages, which apparently are excellent. There's the right one. So mine says Eco Data Science because that's where I pasted it from. Yours should have your name here instead of Eco Data Science because you forked it first. It's worth pointing out now that if you're going to be using version control for your code, which I highly, highly recommend you start doing, you also want your code to be pretty well organized on your own machine. One of the great things about version control is it allows you to work on your code on different computers and other people to work on that code from whatever computer they're using. So, for example, if you have a desktop in your office and a laptop, it allows you to really easily switch between computers. However, in order for your code to not break, you need to always have relative file path names. If your code says Owen/PC/thesis/species interactions, not to pick on Owen, then it's not going to run on anything but Owen's PC. The way that most people I know have solved this is they have a directory in their home directory of their computer called Git or GitHub, which Elise referenced, and every project repository is directly below that folder with a simple, understandable name. The name of that folder should be the same as the name of the repository. And once you have a million things on your computer, You may need a slightly more complicated approach, but this is a great way to start. So just to show you on my own computer, I have, don't know why it's doing that. This GitHub file, it's directly under my home directory, and then these are all repositories that I work on. So you can put this directory wherever you want for now, but I strongly recommend you doing something like this in the long run on your machine. And the last thing you have to do is put in a directory name. I pretty much always just call it the same as the repository. So you would do GitHub intro 2. And then click create project. I'm not gonna, can I do this here? I might already have this on my computer, which will make it very unhappy, but let's check. Yeah, I do. There's also GitHub intro problems underneath it, which we can always look at. So I'm just gonna delete this one and clone this one. So you should see that. It'll say switching to project. And then all of a sudden there are all these new files that you've never seen before. Did this work for most people? Okay, if it didn't work, wave, grab a helper. I see one person needed a helper, anyone else? All right, you've got a helper, awesome. So let's just explore what we got. If you look at this RStudio interface, we're now in something called GitHub Intro 2. It is all these files that we haven't seen before. As a fun sort of bonus, these files called index actually are the presentation that you just saw. You can also write presentations in R using a wrapper called R Markdown, which is a separate tutorial we taught last month and we'll teach again at some point in the future. All by way of saying this is a great way to organize everything related to your work, not just your code and analysis, but also your papers, presentations can all be under this umbrella in a project. Today, we are going to modify this repository. So open up the thing called practicescript.r and type in anything that you want. It can certainly be function and code. You can write, you can assign a variable, but you can also just put the hash mark, which will comment out the code and write a line. So put in anything that you like. You can just put in your name and save it. Everyone following along, more or less? Feel free to interrupt if you have questions. So now you have modified this. This is if Elise were working on the repository for the gardening software. This is where she would have gone in and changed the timing of watering to adapt to Santa Barbara climate. You've made a much smaller change, but it's still a change. So we've forked the repository, we cloned it, we edited it, and now just to be sure there are no other changes, before we go any further, what do we want to do with this repository? Oh, yes. So the most annoying thing about using Git and GitHub by far are merge conflicts, which is when someone else has been editing this while you were editing it, and the changes can't be reconciled. The way to prevent that from happening is to pull frequently. Pull if you know someone else has been working on it, even if you haven't. Polling is also the way that you switch between computers. So get in the habit of doing that quite frequently in your work. Now, it's possible to do all of these Git operations from the command line, but you actually don't have to because RStudio has this wonderful Git interface. So on the top right, I'm going to scoot this over. She'll just move this. Can I move this? Yeah. So you can see it. So those of you who code in RStudio will be familiar with some of these tabs. So environment usually has the objects that are loaded into RStudio's memory. But now you have this new one because you use version control called Git. And this has all of the functions we just talked about. The down arrow means pull, because you're bringing something from cloud, if you will, onto your local machine. And the green up arrow is push. So before we commit these changes, let's just pull, just in case someone else has changed it. You should all get this thing that says already up to date, because nobody's modified Eco Data Science GitHub Intro 2 in the past minute. Good? But if someone had, you would either get a message that said, there were changes, we've merged them accordingly with your version, and then you'd see new files in this file pane in the bottom right. Or you'd get the error message Elise referenced that there was a merge conflict, and it prints both versions of the conflicting lines of code, again, in these files on the right, and you have to open them and manually delete the version you don't want. This is super annoying to do. Try not to put yourself in the position of having to do it. So now that you're up to date, you can commit your changes, which is, again, a lot like saving, but with a message. So I didn't actually modify this, so there's nothing here. So I'm gonna just add in something that says hello, save it. And now on the right, there's something appears that says practicescript.r and it says status M, which means modified. If you click, so what I just did, I did that kind of quickly. I clicked on the thing that says commit, and it brings up this whole separate pane, which allows you to look at all the files that have been changed. At the moment, it's just one, practicescript.r. Sometimes it's numerous files. And this is also, if you move or delete files, that will all come up on here. Anything that reorganizes anything in the repository will appear as a change. Now, what's really cool about this is it shows you the changes you made. So you can see the stuff in green I added, and something in yellow, in red I got rid of. So for some reason it has this line 3 and 3, which are basically the same, but you can see in green I deleted, or I added the hello, and if I deleted something else, it would turn up in red. So you want to kind of glance at this and then put an informative message about the changes you made for your future self. You want to keep it short, but you want it to be something that someone else you're working with will understand what you did, or you in the future will understand what you did. So my commit messages tend to be something like, linear model is working, made black and white figures. I pretty much always commit when I've finished a chunk of code. So let's say you were trying to make a complicated graph or have a model run. Whenever that task is done, I commit. I sort of pause there in the same way that you'd save. I also usually commit at the end of every day. So even if I'm in the middle of something, I'll say, linear model's not working, but I'm going to go to dinner or whatever. So put in your commit message. I'm just going to say tutorial edit for mine. I don't know why this is in all caps, but we'll go with it. And then you just click commit, and it should give you, ooh, cool. This is fun. Let's try that again. So that gave me that mistake, that error, because I didn't check this file. I didn't tell it to commit anything. You have to manually choose which ones to commit. Often there are files that you don't want to commit. Those either might be really big data files that you don't want to store in the cloud, or files that that GitHub has trouble understanding and reading, like PDFs and HTML files. So GitHub has a very hard time, especially with PDF files or images, figuring out what's changed in them because they're not text. And so often you don't commit those, and if there's something you never want to commit, you can actually add a description of that to this file down here called gitignore. So in here, I told it anything that's an RData file, never commit, because I use RData files to store really big objects in my research, and I don't want it to try to put those on GitHub. So that said, let's try committing this one file now that we've checked it. And it worked. It says one file was changed, 3 insertions, those were the lines of code I added, and 1 deletion. Did that work for everyone? Now, what's cool is this little banner pops up reminding you that now you're ahead of the master branch. So remember, all the changes we've done so far on your machine, nobody else knows that you did them. No one else knows that you added code to the gardening software to change the frequency of watering, because you have not put any of it online yet. So until you do that, people aren't aware of these changes. They can't pull your changes and incorporate them into their code. So especially if you're collaborating with other people, you want to be very sure that you push frequently. It's not uncommon for someone to accidentally commit 3 or 4 times and forget to push back to the master branch. Every time you commit, you want to push to the master branch. The only time I don't do this immediately is if I'm on a plane or somewhere with no service. All of this works on your local machine, but you can't pull and push without internet. So let's try pushing and see what happens as soon as that banner goes away. Something else I should mention here. So let's just give this. So that worked. I'll do this. So that worked perfectly. And now if you close it, and go back, so you can close all that stuff. Let's go look at the browser again. We go back to Ecodata Science GitHub Intro 2, or your version, and we refresh this page. You'll see the file you modified and the new git commit message. So look at practice script. I wrote tutorial edit. It says it was modified 2 minutes ago. So now your changes are online. They're part of this repository. Anyone who has access to it can see them. And other people can pull those changes and keep working. Many people are hesitant to use GitHub because they think it's all public. So I should mention here that it's possible to make these repositories private. Because GitHub was created to foster open coding and an open internet, or at least it's grown to do that, their default is that everything's viewable by everyone. But as students or anyone affiliated with the university, you get unlimited free private repositories, which mean the only people who can view them are your collaborators who you've added to that repository. The only difference is when you pull and push, it asks you to log in. And so if we go look at my repositories, all of the ones associated with my PhD are private, and you can see that they have this little lock next to them. So nobody can view those. They work identically otherwise. So that's pretty much everything that we're going to do today. Does anyone have kind of broader questions about how that works? Was everyone able to push successfully and see their changes in their own repository? Go ahead.
Oh, I just, mine was showing up like
Okay, you have a helper. Any other questions? Go ahead.
It's like asking for my
Okay, I think Owen's on it. If you're, oh, do we have Noah? Do you mind?
Yeah.
Thank you.
You want to take like 5 minutes?
Yeah, that's a great idea. So let's take 5 minutes, and then if anyone has broader questions, we can chat. If anyone needs a helper, flag down a helper, and then we'll circle back before we wrap up.
Thank you.
Do you need a helper? What's that?
How do you
Things like you
private?
So,
Simply runs.
like there's no file. So like where do you
So are you, yeah.
Okay.
I made it under my UCSB, but then I changed it.
Is it, well, I'm not sure if it knows if you're a student, but let's try. Just, why don't you just go to your repository and click your repository. Okay, go to your home. So just like
So it looks like you had already.
and your repository is button. And look at private thing and see. Okay, so it doesn't think you're a student. Charging you? Yeah. So go back to your profile. Yeah, and let's see if we can figure out how to register.
Like the files. Change the files.
Do you want to just Google how to put on the student?
Yeah.
Developer?
Yeah,
Because
that's what it is.
yeah, I would do that, and then you may or may not want to create an account. There should be a way to sort of say, I became a student, can you make me start an account?
Yeah.
And then it will give you, takes a minute, but it'll give you what's called like student developer pack. And that includes unlimited repositories. So as soon as you can set that up, when you click that toggle private public, it won't do anything. It'll just send it private. It won't charge.
Thank you.
Awesome. Yeah, sorry, I can't do it right away.
Oh, that's.
Yeah. Oh, you're still up on
It's actually
Facebook.
pushing us through.
Yeah. Can you just like go on GitHub stuff? Yeah. Okay. Cool. I've never really done that. I've always done like 4 projects, and they were like, you spent time actually.
Yeah, no, it's helpful. I don't know what your background is.
I just started the master's program and we're going to use this for our stats.
Yeah.
And also, I think it's just one like HTML class. And now it's really helpful to find their subject in the morning.
Whenever you like come to the papers, you get to call you
Oh, that is really nice.
Dig into something that can relate to
Yeah. Yeah. So I would try that.
Cool. The people who created it.
Yeah, I knew about this with Allison.
Yeah, okay. So you can also solve it.
Yeah, it looks like it.
Super
So it looks like it.
Oh,
and that link is.
oh, cool.
Yeah.
Yeah.
Really
Cool.
It's not as big for people to like need it and like now I can.
Yeah, it's pretty simple for some reason. It's like,
Yeah, you save it.
yeah.
You have to choose which file. It's sort of, I think it is like multiple layers.
Yeah.
So you're like saving it to your local machine, and you're choosing what things you want to save to.
There's one like
I actually I interface very rarely with like online GitHub, except for when I'm like, so like people that publish papers or like I put online or from that collaboratory, Alexa or something, she'd be like, oh, just like so I'll go to her account, I'll find this, and then I'll just basically use it. Yeah. You can't really you don't really open or download the files from. Yeah.
Okay, so this website is just incredibly useful for walking through setting up Git if you haven't done it already and troubleshooting problems. Chapter 15, RStudio Git GitHub Hell, particularly relevant for people who are struggling with this. So this is where I go if I have issues with GitHub. Please bookmark it, write down the name, and if any of you are active on Twitter or just follow people on GitHub, this is one of the best people for RStudio stuff to pay attention to. The last thing that I realized I didn't discuss is creating your own repository. So we covered using someone else's code, but realistically, when I'm coding, most of the time I'm working by myself, at least to start. So I just wanted to very briefly show you how that works. This is a repository that already exists. There are a lot of ways to create a new repository. You can do it from RStudio. I usually do it from GitHub and then go through the exact same cloning process that we already did into a RStudio project on my local machine. So super quickly, if you want to create a repository, click the cat, the octocat in the top left. It will take you to your home page. And click the green New Repository button. We had a lot of people ask whether or not they're students, how to tell if you're a student, developer, registered with GitHub. For me, the way I tell is if I click private, it doesn't try to charge me any money because I get unlimited private repository, so that's how I would check. And that is what should happen for you guys. So I'm just gonna put test repository in here. Again, you want a short, informative name. You don't really need a description, and you don't need to check this box. And because I belong to multiple organizations, you can actually create this under multiple accounts. This is really relevant for people working professionally who have access to a group account. So Elise might have a personal GitHub and access to a work account that manages a website, for example. So I'm going to just create this under mine. I click private, but I'm going to change it back to public so that you guys can follow along, although it won't change at all if it's private. And click Create Repository. It takes it a minute. And then just like when you forked a repository, we'll take you to something that says your name / repository name. So at this point, it's identical to what we did before. Now you can clone it to your own machine. And it takes you to this kind of special screen that has the exact same thing as before. You can copy this link. This screen only comes up the first time that you create a repository. After this, it will just look like the other ones did. I'm also going to show you how to delete a repository, which it really doesn't want you to do, or rather wants you to be very sure about. So you go to settings, you go all the way down to the bottom into the danger zone. So this is where you can make something private. So you can create repositories as private. You can also start working on them publicly, decide, you know what, I really just want to not have this code visible for a couple days, weeks, months, whatever, and make it private. Give it to someone else. I don't actually archive repositories, but that's an option. Or you can delete it. So I'm just going to delete this one because I don't want this repository in my account. And in order to do that, to be extra sure, it makes you type in the name again. So I'm just going to say, I understand the consequences, delete this repository. And you have to log in again. And now it's gone. So I think with that, you should have a sense of how to go from nothing to having a repository of your own that you can make changes to, commit, push, pull, and have great version control of your own work or of team collaborative work. So I'm going to pause there. You guys are welcome to stick around if you have any questions or want to keep troubleshooting stuff with us. This technically goes until 1, so we're early, but you're also free to go. And thanks again, Elise, for leading us through the presentation.